In the last presentation, we completed the introduction of the signals, and I also gave you one example in which we were at the temperature from 9 a.m. in the morning to the 9 p.m. at the night. I also told you in electrical and electronics, the signal is nothing special but the change in the current and voltage with time. So in this presentation we will move forward with our signals and we will see what is an analog signal. Before actually going to the actual idea, let me first tell you the difference between the analog clock and the digital clock. Why we call this analog and why we call this digital. So let me write it down. This one is the analog clock and this one is digital clock. So let's first talk about this analog clock. In this you can see we have three hands. The first one, this one is the hours hand, this one is the minutes hand, and the small one is the seconds hand. So we can say that this analog clock or this clock can have the time as hour, then minute, and then second. So it can take any value in 24 hours. Now let's see what happens in the case of digital clock. This one represents hour and this one represents the minute, but there is no second in this case. Once we have 60 seconds passed, this 12 will change to and we have 13. We cannot see what is going in between this 12 and 13 because it is not allowed in the digital clock. Either we have 11, 12, 13, 14, 15, not 11 minutes and 10 seconds. It is not allowed. That's why this is digital, because in digital we have certain levels like this. Let's say this is 11 minute, 12 minute, 13, and then 14. Either you will be on 11 or 12 or 13 or 14. You cannot be in between 11 or 12. Like this is 11 minutes and 30 seconds. You cannot have the value equal to 11 minutes and 30 seconds because second is not allowed. This level, this intermediate level is not allowed in digital clock. On the other hand, in analog clock we can have 11 minutes and 30 seconds definitely. That's why we call it analog, because it is analogous to the time. We have every values in the given limit. So this is a small thing which will help you to understand the analog and digital signals. Now let's move to the actual thing here. You can see Tmax. Tmax is the maximum temperature, and let's say this plot or this graph is for the temperature, and we are measuring the temperature from the first of the month, and this one is for the last day of the month, that is 31st, and we are measuring the temperature like this. Let's say without for any reason like rain or something, we have the temperature lowered from the 16th of the month. So this is the plot, and we can see that this particular plot is analogous. This one is analog. Why this is analog? Because you can see that each and every value is possible. From 0 to Tmax, the temperature in, let's say, degrees Celsius, we can have any value. Like this one is 27 degrees Celsius, and we can have 27.8 degrees Celsius. In the same way we can have 27.88 degrees Celsius, and all the intermediate values is allowed, and let's say Tmax is 47 degrees Celsius. So from 0 degrees Celsius we can have any value between the 47 degrees Celsius. So this one is analog because it can take any value within the given limit. So analog signal is the signal which can take any value within the given limit. Now as we are talking about the digital electronics, let's change this Tmax by the Vmax. This Tmax is Vmax. Vmax is my voltage, and this is 0 volt and this is V volt, that is the maximum voltage, and let's say Vmax is 20 volts. So it can take any value between 0 and 20 volts because it is an analog signal. Now we can move to the next type of signal, that is the discrete time signal. So let's study what is a discrete time signal, because it is important to understand this signal before we move to the digital signals. So let's see what is the discrete time signal. The signal which is defined for the discrete interval of time is called as the discrete time signal. So I will write this thing down so that you can have a better or proper definition of the discrete time signal. The signal which is defined, which is defined for the discrete intervals of time is called as the discrete time signal. Now let's understand it with the help of this graph. Before that, I will clear some space so that we can understand it easily. Okay, I will copy this down and then we can analyze it. So let's copy and then paste. I will drag it down and now we can analyze it. In discrete time signal, the time axis, that is my x-axis, is discretized. By discretized I mean, let's say we are measuring the temperature on 11 o'clock daily. So this is the 11 o'clock of the first day, then this is for the second day, and this is for the last day, and this one is for the second last day. These are for the different days and all are on the 11 a.m. So what between the 11 a.m. of the first day and the 11 a.m. of the second day? We don't know. What is the temperature between the 11 a.m. of the first day and the 11 a.m. of the second day? So this definition, this value of the temperature is not available to us, so I have to remove it. So let's rub it down. Okay, in the same way, we don't have the value of the temperature between the 11 a.m. of the last day and the second last day, and the same thing will be applicable for the other days of the month. So this is how a discrete time signal looks. We have discretized the time axis. This is not proper, but you can draw it proper. And in the same way, we have to eliminate these portions also. Now this one is the discrete time signal. We have the definition of the function. In this case, it is the temperature for the discrete time values. Let's say this is t1, this one is t0, t2, all the way to tn. So we have the value of the function at t0, then t1, t2, all the way to tn. The value of the function we have for this times only. What is between t0 and t1? We don't know, because we have not monitored the function for that particular time. So this is what a discrete time signal looks, and you have to know one thing, that the signal is actually analog. The change is definitely analog, but we have not monitored this particular sections, so we have a discrete time signal, and the discrete time signal is the subset of analog signal. So this is an important thing to know, and all real life signals are analog signal. And I think this is all. We are already pushing the time, and we have learned two things. The first one is the analog signal and the second one is discrete time signal.